Hi, what we want to do is to consider how to understand the domain and range of a function. Um, they are not too difficult concepts. With enough examples, there are things that could be easily grasped. The first thing we look at is the domain, and of course, that will be the x's that we are allowed. So, for this particular question, we have been streamlined to just x's between -2 and 4, and this is exactly our domain. If we were not given this, then we would have used this larger set as our domain, but seeing as we've been restricted to -2 and 4, that will be our domain. Hence, I'm going to answer A by saying that the domain of f is all the x's, all the x's between -2 and 4. We will come to sketching of the graph after we've considered the range. So what you want to look at is all the values that f of x will give you when you substitute the values of x. And this is what I mean. It's better to see the function as a huge engine which churns out values of f of x. So when we put in the values of x, for instance -2, when it goes in, the engine for x plus 3 then churns out the value of f of x. So in this case, when you have 4 and you put in -2 plus 3, it should give you -8 plus 3, which gives us -5. So the value of x here is -5. If we put in x being -1, then we have 4 into -1 plus 3, which gives us -4 plus 3, and that gives us -1. So this gives -1. Okay, if we put in the third one, when x is 0, you will have 3. In this case, there is a pattern that develops. So if you look at -5 and then you add 4, it gives you the next one, which is -1. If you add 4 to -1, it gives you 3. So the 1 for 1 should give us 7, and the 1 for 2 should give us 11, and the 1 for 3 should give us 15, and the 1 for 4 should give us 19. Now all of the values here is then called the range. Remember what I mean by that, and not just these values. What I mean is every value in between 19 and -5. For instance, x here tells us that we could choose any real number between -2 and 4. So we could have used -1.5, and we would have got something entirely different out here, and that will still be a part of our range. Depending on the domain we've been given, it's really important to note that our range is not limited to just these numbers alone. However, the range is never less than -5, and it's not greater than 19 as far as this question is concerned. I hope this makes sense. All the numbers we are given here could have been more. We have just chosen this number because we need some numbers at least to explain this situation and to plot our graphs. However, as far as this function is concerned, it is continuous, which means there are many more numbers in between -2 and -1, and any one of those numbers would have been valid enough to give us a range here. So our range is not limited to these numbers alone. There are other numbers that could be in between these numbers. However, we cannot have anything less than -5 or greater than 19 as far as this question is concerned. For instance, -6 will be wrong because the allowance of x we have here will not churn out anything that is less than -5. And 20 will also be wrong because the highest we can have from these numbers that we are given is 19. Hence, to write down the range of f, I would say it is between -5 and 19. Please note that there is a change in notation here as against the domain. The domain generally represents all the inputs and the range represents the output. So in any case, this could have been y. If, for instance, the function written here was y equals to 4x plus 3. In that case, this should have been -5 between, it would have given us our y between -5 and 19. So in this case, our range is -5 less than or equal to f of x, which is less than or equal to 19. We are now left with sketching the graph. And there you have it. Remember that the highest here has to be at 19 and the lowest has to be at -5. Hi, here's another example. We're told to sketch a graph and then write the range of h. Just like I've said in the last example, this is the domain. This is the domain. Okay, which is simply all the x's that we are allowed to use as the inputs. So if we input that into this function, all the h of x that we are allowed will be our range. The graph I've sketched right now on the screen is the graph of h of x equals to x squared. And this is what it normally would look like. Because we have been given just x squared plus 3, what it means is we are going to lift this graph 3 spaces because of that plus 3, 1, 2, 3. So we lift it 3 spaces to come to its sitting line. So before it was sitting on 0, now it will be sitting on y equals to 3. So the point there will be 3. So if we are going to determine the range of this graph, naturally, we cannot have the negative part here, so we would have to delete it. And the reason is because we are not going to be able to use any value of x here because x cannot be negative. So there is no way that we are going to need any value of x here, which includes this arm of the graph. The values of x, which creates this arm of the graph, is contained here, and we won't be needing it. Hence, I am cleaning this up. Naturally, it means that I could also afford to clean this up without any consequence whatsoever. So the only thing we have is this arm of the graph, which means that that only confirms the domain. The domain is from x equals to 0 up to infinity, if you like, as it continues to move towards the right. However, it does not affect the range. The range begins from the lowest point, which is your h of x equals to 3, and it continues till infinity because this line does not stop. It continues to go on and on. it continues to go on and on. Hence, the range will be all age of x that is greater or equal to 3. Here is the third example. So the first thing we want to do is to try to sketch the graph. And one way to do that is to expand this and then factorize. So if we make an attempt to expand it, you have 3 into x minus 1 over 6, and then x minus 1 over 6 minus 25 over 12. And this gives 3 into x squared minus x over 6 minus x over 6 plus 1 over 36 minus 25 over 12. And if we open the brackets, we will have x squared minus x over 2 minus x over 2 plus 1 over 12 minus 25 over 12. So this will give us x squared minus x. Then you have minus 24 over 12, which should give us x squared minus x minus 2. Okay, so now that we have expanded, we can factorize. I think there's a 3 here that I'm missing, so it should be 3x squared. Okay, so if we factorize, we would have negative 6 by multiplying 3 and minus 2. So the two numbers that will be required will be negative 3 and 2. So we will have 3x squared minus 3x plus 2x minus 2. So if we factor out 3x, we have x minus 1, then plus 2 into x minus 1. And then factorizing further will give us x minus 1 and then 3x plus 2. So we have an idea of what the roots will be like. Okay, so we know that the roots will be at 1 and negative 2 over 3. So we could say that this should be negative 2 over 3 if you like. And we could say that this is 1. So the roots will be at those 2 points. I know because this is x minus 1, and if we were to solve it, if this were equal to 0 and we were to solve it, we get x equals to 1, and we get x equals to negative 2 over 3. Now that we know the roots, we need to figure out what the minimum is, and that is why writing in this form matters. Again, if you are an iGCSE student or a GCSE student, you will be required to know how to write a quadratic equation in this form. And one major reason that will be required of you is so that you can easily pick out the maximum or minimum from a quadratic function. So from here, I can pick that the minimum value of f is, so you know what you have, or maybe I should say the minimum point in this case. That might be a much more appropriate word. So the minimum value will be x equals to 1 over 6 and y equals to negative 25 over 12. This is where the minimum will be. And remember, you see that I wrote 1 over 6 as positive here on purpose. So even though this is negative, you should change it to positive. And this one you don't change at all, you write down exactly the way it is. So now that we know the minimum value, we know that that is 1 over 6, which is going to be around here. Okay, it's going to be around here. That's 1 over 6. The negative 25 over 12 will be negative 2 whole number 1 over 12. Okay, so if you like, you could write this as negative 1, and then here negative 2. So negative 2 over 12 will just be somewhere here, and that gives us an idea, a fair idea of what the minimum will look like. The next thing we are going to do will be to sketch our graph. We know the minimum point, which is also the turning point. Okay, so when we are sketching, we'll put that in mind. That is the minimum or turning points. Minimum or turning points. We would have something that looks like this. So we cut through negative 2 over 3. Then that will be the minimum point. And then you have this part also cut through 1. And then here you have the minimum point. Well, I've not done that properly. So let me try and bring that, because it must be smooth. That's better. So that looks like what our graph is. Now, what the range will be from the lowest point here and then upwards, since we don't have any restriction as far as the top part is concerned. It may be good to just put an arrow here to show that this graph continues. So we would have the range as any f at x greater or equal. So the range is every f of x that is greater than negative 25 over 12. Well, I hope this helps. Okay, if you need more classes on this, you just reach out to me via email, which you can find on my channel, and then we can discuss more. See you next time. Bye.